you see my screen?
You
Okay.
can see your screen. Thanks, Joel.
Great, great. And this is being recorded as it always is. So the main item in the agenda is Susan Gregurick will be talking about ML training, workforce and benchmarking, and ethical AI. So that's we're moving forward on ML on a bunch of fronts in the consortium. So that'll be very exciting. So we have CD2H N3C offboarding process, and I understand that one is supposed to give people heads up if people are leaving. If somebody on the panel wants to say more about it, please jump in.
I can actually just speak briefly about that. An email was sent to N3C all hands just a couple of hours ago. This is just to thank everyone on the projects for the 2 years of service, and also realizing that there might be folks who are moving on to other opportunities. And we would like to make sure that folks who have moved on to other projects have been able to offboard themselves from N3C and CD2H projects. So this is a quick little form that shouldn't take more than 1 or 2 minutes to fill out. It would give us, the administrative team, an idea of who's moved on, and we can make sure that their files and everything are stored properly. Thank you.
And if somebody is leading a team where somebody is off-boarded, I assume, I looked at the form, that they can fill that out as well. It's not necessarily just the off-boardee.
That's correct. Yeah, the leads can fill it out, or somebody on the team who knows someone who has moved on to other projects can fill out the form as well.
Yeah, no, it's a great idea. Certainly in longer-lived projects, especially big consortia where people don't necessarily know each other that well, you do aggregate a fair number of people who once had something to do with various efforts who've moved on. And certainly we've been around long enough that becomes an issue, obviously.
Yes,
so,
and it would reduce the number of emails folks would get from us, because we've had people reach out to us saying, please stop sending me emails. So this would also help that.
Great. Oh, that's wonderful. Okay, so upcoming presentations and N3C Community Fora. So March 28th, next week, Good Algorithmic Practice Initiative Rationale and Overview by David Sarner. Update from the Logic Liaison Team by Joanna Lumba. Update from Education and Training Domain Team by Sean O'Neill. And then April 4th, data quality considerations for evaluating COVID-19 treatments using N3C. How to accommodate missingness, their role in analytic decision frameworks, and the MLP team update, past clustering pipeline, and GAP insights. And after that, rare diseases and the rare disease networks, the new N3C public health dashboard demo, and finally, April 18th, semantic clustering and the monthly Recover Long COVID team updates. And you can read the speakers' names. Okay, so we are up to 4.5 million COVID positive cases and 14.3 billion rows. So this thing is getting larger and larger all the time, with obviously a much greater variety of data thanks to PPRL linkage and the advent of NLP extraction from medical notes. Okay, so Susan, I'll stop sharing, and you can share your slides. Look forward to your talk.
Thank you very much. You have some impressive statistics and also some impressive speakers coming to talk. I can't wait to hear their talks as well. I need to display settings change, and then Will you just tell me if this
That
looks
looks good.
reasonable to you? Okay, awesome. I hope this isn't too much of a bait and switch, but I'm going to tell you a lot about what is happening in data science across NIH.
Great.
That align. Oh, good. I'm glad you. I hope that you'll
That's
find this
fantastic.
interesting.
That's great.
It'll be quite a whirlwind tour. I do talk a little fast, but you are welcome to. I'll send the slides. You're welcome to them.
Oh, that's wonderful. This gives us a great context.
Absolutely, and there's a lot of opportunities. So my main take-home message is, we're just starting this journey. We're on a path. I think we're on a good path. You'll tell me if I'm wrong, but there's a lot of opportunities here for you to engage us across NIH, my office in particular, and to help us as we take this journey together, make the right changes and really have the positive outcomes that we all want to have for COVID and beyond, for rare diseases, cancer, for all of the important missions of NIH. For those who've heard my talk before, I do use the same use cases. They're still pretty valid. And I'll talk about each one of these use cases. The first one is the most pressing one that many of us are dealing with, which is just how do I actually create my data management and sharing plan that I will need to do by January 25th of 2023. And really, how can I really take heart those FAIR principles of data sharing and put them into practice? What do I do? Where do I start? Once I've made my data usable for others, how can other people, and this is pretty important here for NCATS, I'm sure, is how can I look at rare diseases in particular, as an example, pediatric cancer, but that's not the only example. How can I look at those data sets across many different platforms, aggregate those data for analysis, when it's a complicated system out there, as you're probably fairly well aware, but if we do enable that, think of the science that we can accomplish. And then finally, I don't know if I'll talk too much about all of our efforts in AI, perhaps just a little bit, but we have a big push in ethical AI and bridge to AI, as you're probably aware. So all of these use cases are supported and enabled by our strategic plan for data science to support common infrastructure and novel technologies and either specialized platforms or, for example, leveraging the cloud. How can I also leverage industry by adopting and adapting from other fields? How can I enable biomedical data science and the workforce through improved programs and novel partnerships, potentially with other agencies or nonprofits? How can we enhance data sharing, data access, and interoperability such that our supported data resources are fair, they are trusted, and they are safe? I'll explain, and caring, I'll explain each of these. How can we ensure the security and confidentiality of the data that we have in our repositories in accordance with our requirements and our applicable laws? With the community input, how can we promote and refine data standards and data sharing, data vocabularies and ontologies and new concepts, for example, FHIR? And then finally, to improve the ability to capture, curate, validate, and store and analyze data, clinical data, for biomedical research. These are all really important goals. It breaks down a little bit differently. I'll show you a graphic of these goals and how we're working on them. But at the heart of this is our office. It's a tiny office. I see a couple of my colleagues are here from the Office of Data Science Strategy. We are a coordinating office, like most of the offices in Deep Poughkeepsie. We work across NIH, across all of the institutes and centers to help develop and implement a vision for a modernized and integrated biomedical data ecosystem. We want to enhance a diverse and talented data workforce, both here at NIH and in the community. And we want to provide strategic partnerships that do enhance data, that enhance the technologies, enhance methodologies. This is a way of looking at the strategic plan that I showed you 2 slides ago visually. Each one of these goals that I told you about is a goal in the strategic plan with very specific implementation teams. And working across the NIH, we're working to, for example, support data infrastructure, connecting data ecosystems, providing new data management tools, enhancing our workforce, and then working on policies to promote data sharing. Across NIH and across our 23 institutes and centers, we have more than 190 staff working together on the implementing different types of data science activities. I'll tell you about a number of these activities, but I sort of want to give you an impression that this is really a team effort. And there are a lot of people, many of whom may be on this call today, who are supporting data science across NIH. And for that, we are always grateful for their efforts. And through our work together, we have accomplished a lot. Let me tell you a little bit about what we're doing to support fair data and data sharing, creating and enhancing repositories for trust, and implementing the data management and sharing policy. And the first thing that I want to tell you about is something that you're, I'm sure, very, very familiar with, which is that on January 25th of 2023, researchers will be required to prospectively plan for how their scientific data will be preserved and managed by submitting a data management and sharing plan, I believe likely at the time of your application. Your plans will tell us how you plan to manage that data and share that data with any accompanying metadata, and taking into account any potential restrictions or limitations for data sharing. The plan also allows you to justify a budget in the extramural awards or part of your technical contracts for data management. So it's not an ask without a budget. This policy applies to all research funded or conducted in whole and in part by NIH that results in the generation of scientific data. So it does exclude activities such as administrative data, training, for example, would also be excluded, and infrastructure development or non-research activities. But by and large, a vast majority of our researchers in the extramural grants and contracts and in the intramural space will be developing and submitting data management and sharing plans. So there's a lot of activities happening at NIH to support this policy. This spring, the Office of External Research will provide additional resources through a website. So I look forward to that, as well as training opportunities. I want to tell you a little bit about some of the work that we're doing here to support the training and information about creating and managing data in partnership with the National Library of Medicine and working with the Data Curation Network. So if you don't know about the Data Curation Network, it's a project that's funded by the Alfred P. Sloan Foundation. It's comprised of professional data curators and data managers, data repository administrators, and discipline scientists from academia, from nonprofit. And the goal is to basically enhance our understanding and our use of the Curation Network to support our data management and sharing policy. We're going to be offering a number of training activities that focus first on our researchers. This will allow researchers to understand the role of their institution's libraries and the curation resources in order to create data management plans. The second training will focus on program officers and other community colleagues to provide training on how you review and evaluate data management plans and what are some types of metrics that you might want to look for. And the third effort will focus on training librarians and repository owners and other curations of data. And then finally, there'll be an in-person hands-on workshop for library creators as sort of a bring your own data workshop. And all of these efforts are expected to help support our data management and sharing policy as we make available different types of trainings and tools for our communities, our researchers, our program officers, and even our library curators. We want to help people think about, I love this sort of acronym here, think about ways in which you can check files and understand or try different formats, understand if you're missing information, how you can transform formats and evaluate the fairness of your data. Everything that we do will be made available to our researchers, our program officers, and our repository owners through a website. So all of the materials will be made available. And this is just one of the ways in which we're supporting the data management and sharing policy. But there'll be additional activities as well. So stay tuned as you look at the Office of External Research and their website so you can learn all about the different ways we're implementing this policy. But I do want to give you a sense that implementing fair data sharing is not a one-size-fits-all activity. There's a very vast array of research that happens here at NIH, and we have to accommodate that in many different ways. Our first stance, of course, is that if there is a community-supported data repository, then that should be the first choice where one would go to share their data. There's a listing of the NIH-supported open access data sharing repositories, as well as the Generalist repositories on the BMIC website. If you Google BMIC NLM, you will get that fairly easily. It's a nice website to navigate all the different repositories you can think about. There are other activities such as supporting data sharing through the supplemental materials on your publications in PubMed Central. All of that data and materials is in AWS on the Open Data Platform. You can also share data through Strides, and I think in my talk I'll tell you a little bit about ways in which we're sharing data in Strides, and then I'll tell you about a new initiative to knit together Generalist repositories for sharing data. But there's many different ways in which we can think about sharing data, and so we have to think about all of them. So as we're getting ready for greater data sharing, we want our repositories to align with the OSTP characteristics for data sharing repositories, and you'll see them listed here. They're fairly, I think, fairly well understood in terms of assigning unique and persistent identifiers to your data, planning for long-term sustainability of your resource and of your data, thinking about ways to measure impact and reuse, looking at security and integrity, providing tracking and provenance. There are other ways that we can enhance data resources for improved data sharing, and I borrowed this slide with permission from my colleague Ingrid Dillow. So you can see that supporting data repositories to enhance sharing, findability, accessibility, interoperability, and reusability, FAIR, as well as the trust principles is a goal for NIH, and you can see the trust principles here in terms of transparency of the scientific repository services, the responsibility to ensure authenticity and integrity of the data holdings, ways to think about a user-focused and targeted user communities, sustainability and preservation of the data holdings, and then of course the technology. So we want to support both of these important principles. And we understand that at NIH, there's a variety of different repositories and knowledge bases that come in different sizes and complexities and different levels of maturity. We want to bring value to the data and to the communities and allow those resources to enhance their ability and readiness to adhere to these characteristics of a data repository from OSTP, as well as the FAIR and trust principles. And so with that, for the past 2 years, we have supported supplemental funding for existing NIH repositories to align with the FAIR and the trust principles that I just talked about, and also to evaluate their user usage, their utility, and their impact. So you'll see both of these notices and OTs from 20 and 22. And the thing that we are supporting, of course, is to provide funding for all sizes of repositories at different ages and stages, to increase the fairness and the trustworthiness of their repository, to improve their usage, utility, and impact. In 2021, we supported 14 awards. You'll see the ICs that we supported. Including in these awards were 3 intramural repositories from NIAID, from NIEHS, and from NIDDK. So these activities are not just for the extramural community, they're also for the intramural community. And again, we are supporting this in this year as well. But improving the data repositories is sort of just one side of the equation. We also are looking to improve the data, make it more fair and more AI ready. And making data more AI ready is not simply formulaic. It requires an engagement and feedback from the users and the use cases. There are ways in which we can improve data for AI readiness. That could be, for example, thinking about the persistence and noise, or the uncertainty of the labels or the metadata, or even the way that we can impugn new metadata. This past year, and this year as well, we have supported activities to make existing NIH data more fair and AI ready by allowing researchers to bring in collaborators in biomedicine, data management, artificial intelligence, and computer science. We've supported 36 awards this past year, and we anticipate even more awards coming this year. And you'll see the ICs that have participated with us and some of the interesting data types, including imaging, electronic healthcare records, omics, and interestingly, speech. And speech was actually one of the most popular type of applications that we received last year. Finally, we are also enhancing the Generalist repositories to increase their ability to implement consistent capabilities across, you'll see here, the 6 Generalist repositories we're working with, to provide better access and discoverability of NIH-funded data, to conduct additional training and outreach on fair data practices and data management strategies, and to engage the community for greater secondary reuse of data. We're really thrilled to partner with the Generalist repositories. And so I hope what you see is, from what I've just shown, that we're thinking about many different ways in which we can support fair data sharing across our data ecosystem. We are certainly interested in listening from you in terms of ways in which we can both retrospectively and prospectively enhance the fairness of data, enable better data sharing and secondary reuse of data, improving metadata capture and extraction at the time of the experiment, allowing greater discoverability of that data, and thinking about new on-demand data harmonization. I highlighted this because I think that the N3C activities illustrated what you can do during a pandemic for very large-scale data harmonization, and it's really a highly effective use case for data harmonization. We often hear a lot of discussion about moving forward, how will we work in a heterogeneous data world? Thinking about ways in which we can connect our data repositories and our knowledge bases for greater scientific discovery, and there's some really interesting lessons learned from the data translator. And then better ways in which we can store and manage and integrate in different and diverse data types. So I've heard it said that if data is like oil, then software is the refinery. So I want to just tell you a little bit about some of the activities that we're doing to enhance software through our strategic plan for data science. We have, for the past 2 years, enhanced existing NIH-funded researchers to enhance their software, to bring in new collaborators and new research and new software engineers, to make their data more cloud ready, or to encourage hardening of the software. And I bring this up because the applications for supplements are due on April 13th. So there's plenty of time to think about ways in which you would like to enhance your software for a greater usability in an open science way. And I'll tell you about some of the things that we've funded. For the past 2 years, we've funded a number of applications. This past year, 41 applications to improve the reuse and effectiveness of NIH-developed software, and again, to bring in those new collaborators and clinical scientists and software engineers. This is just an example here, and one of the groups in Texas ported their biomolecular software. Actually, this is a density functional calculation software to Azure, and then they provided outreach to their community in the Latinx chem community. So it was a really pretty cool supplement. What do these supplements support? The robust, sustainable, and scalability of existing software and workflows, investing in software tools that have a high value to a particular scientific community, and that these supplements will enhance their impact and leverage best practices for software development. And then again, support those types of collaborations that are needed to really enhance the software. Here is sort of the general areas that were funded in FY21, and you'll see that it's no surprise some of these activities have highly effective software, drug design, biomolecular simulations, for example, and new areas that are starting to come up in fire and clinical data software, public health software, and importantly, speech. So I hope you'll consider this program as you're thinking about enhancing your software. I just want to point out that this past year, we've developed an FAQ for software best practices. This provides information on how to make your software open and citable, and ways in which you can allow software use for medical or clinical settings, ways to think about software vulnerabilities. Most importantly, metadata for software. This is something that I certainly would love to have the community's input on. And then benchmarking and provenance. I hope that you'll look at those software FAQs. We're interested to hear from you. If you think that there are opportunities to leverage software enhancement and hardening that we can learn from other agencies and organizations, for example, the Chan Zuckerberg has a very interesting software enhancement program. Are there ways to enhance software beyond our current programs, such as looking at low-code platforms or the penetration of edge computing or computing on device, and even new activities in homomorphic encryption, even though it's not quite scalable at this particular moment? And finally, I think maybe not completely finally, but finally, I want to spend a lot of time on thinking about connecting data and platforms and creating sort of an ecosystem where we can really think about interoperability. And I'm sure this is a great interest to the N3C community. Many of you are probably working in this area. And I borrowed this slide from your colleague, Melissa Hendel, who attended our NIH Cloud Platform Interoperability meeting this about a year ago now. And this is really the way to think about interoperability, as you may have heard, from many different viewpoints, from the ways in which data can be licensed or combined only with very specific permissions, to the controls that must be provenance for looking at data, the systems and the toolkits that are needed to make data and platforms interoperable, and then the mere fact that data has different data models, different terminologies, and different ontologies. And so there's just the lift in many different aspects to think about ways in which we can create an interoperable data ecosystem. But there are places where we can start. And so this is one of the first efforts that we did here at NIH, to look across a number of our institutes and centers and think about ways in which we can integrate the front door, the data access processes. There are large programs that are supported by NIH and NSF that are designing integration platforms for greater access. This is also happening in the UK, as you're probably aware. And there are community standard groups like GA4GH that are also thinking about this. On top of all of that, there's the administration's cybersecurity goals to move towards a zero trust environment. So we have to really think about our security posture in a much more rigorous way. And so that's something that we've been thinking about for the past 18 months, and we've made a lot of progress. In the very beginning of this journey, if researchers wanted to co-analyze data, let's say that they have access to the data, they've gone through the data access committees, and they want to now co-analyze the data sets. It's quite a bit of work to just log in, get access, and then push the data to the compute environment. This just shows you one particular example across two different repositories. This just becomes much more complicated if we add on a third or a fourth repository, as we would likely want to do. So we set out to implement a researcher auth services. This is probably quite compatible to some of the work you're doing with, I think it's called UNA, to provide a sort of a one-stop shop for researchers, either intramural or extramural, to log in with a particular credentialing system and then gain access to the data sets and the tools that they have permission to have access to. And when we started this out, we started with ERA Commons. So we provide unified login credentialing system, utilizing ERA Commons, now moving towards InCommons, ORCID, and eventually potentially Google. The reason why we do this is that it's much more efficient. It provides, instead of those 5-step processes for login, just one authorization. Currently right now, it's leveraging dbGaP. Everything is multi-factor authentication. We're moving towards a zero trust environment. So we are moving in step with our administration's goals in cybersecurity. And it allows us to have a much higher level of access and security. So this is where we are. And of the systems that are able to connect to RAS for authentication, you'll see that it's, some of them are more well-known systems. Kids First, Biodata Catalyst, the Cancer Commons Research Data Commons, the Anvil, also NCBI's DB-GAP, all of us, and just of last week, the NIMH Data Archive, NDA. So we're moving to a larger number of platforms that can authenticate and eventually authorize data through RAS. I think at this point we have potentially another 10 that are sort of in the phase 3 pipeline. Why would we want to start here? It's not the most glamorous thing to do, but there's a particular reason. By enabling a single sign-on for authentication and a consistent way to manage authorizations of data, we're able to really think about how we can actually integrate different platforms together with the ability to provide researchers ways to analyze data across different cloud platforms so that you can do that use case where you can think about the amount of data that would be required for a statistical analysis across these different platforms, or to bring together multiple data just to do a simple analysis. So this is one of the goals of the NIH Cloud Platform Interoperability effort. And this is sort of visual, and thanks very much to the NCPI fall meeting this past year for letting me borrow their slide. But it's a way to think about looking across many different portals in a consistent way to find the data of interest, and then passing that to the different platforms in order to create the workspaces and the analytics that are of interest. And so with that, I'll show you just an example of a use case. This is a use case from Melissa Wilson. She's interested in examining sex as a biological variable. She wants to assess the state of the X and Y chromosome calling in a particular Terra workspace, which she likes to work in, but she would like to reference data in Anvil and Biodata Catalyst in the Kids for Research data commons in the Kids First data sets. And so what she will do is, because Terra supports the DIRST servers from Anvil, from Biodata Catalyst, from Cancer Research Data Commons and Kids First, she's able to search for those data on those 4 platforms using either the manual manifest or PFB. And then she's able to point to those data in DIRST and do the analysis in the Terra platform. What she doesn't have to do is to copy the data across these systems. So she doesn't have to duplicate or copy data. She can simply utilize RAS, log in, get the access to the data, point to it with DIRST, and then pull it into her Terra platform and do the analysis. And this means that she's able to analyze about 11 petabytes of data in Terra across these platforms. And although this is sort of a one use case and it's not hardened in any way, I think it points to what can be done in the NCPI activity. So where are we going? I want to point out to you a paper that's still on bioRxiv, but it's probably worth reading just because I think it has some really interesting ideas about how we would create interoperability by thinking about secure and authorized fair environments. So SAFE is the term that they like to think about. This paper outlines concepts for how we can authorize users in an authorized environment and then set up an interoperability framework from a governance model that allows us to expose the APIs and enable access of these systems for the analytics that is of interest, sort of like that use case. Oh, shoot, my cat's up on my table. Okay. So sort of like that use case that I just illustrated. So this is a way to think about data governance as well as platform governance, allowing us to also think about ways in which we can update our security posture. We do need to think about advanced data management incident capabilities across different platforms, because now we are enabling a fairly complicated aggregated data analytics that would require some more advanced search capabilities and strengthening our ability to pull in different workspaces across different computing environments. So again, I think this paper is sort of an interesting look. If this program is of interest to you, I just want to highlight that There is now a call on the street for an NCPI Administrative Coordinating Center. We certainly would invite applicants who are interested in technical, administrative, and coordinating support for the NCPI and IH Cloud Platform Interoperability Program to submit an LOI by April 15th. Full proposals are not due until June, and you can certainly send in questions to our email address. But this is sort of one of the ways in which we're thinking about interoperable systems. There are others, and so I'll just tell you a little bit about them. There's a Common Fund data ecosystem. It's creating a functional ecosystem across most of the data coordinating centers of the Common Fund. They want to enable users to query and access Common Fund data sets across those DCCs. They're thinking about ways in which they can sustain the Common Fund data and their tools and ways in which they can train users. So the Common Fund data ecosystem has been instantiated, I'd say, for probably about as long as we've been working with RAS, so about 18 to 24 months. And they are continuing to work on activities such as enhancing their Common Fund data ecosystem portal for data discovery, and ways in which they're considering cloud workspaces for analysis. So I would also stay tuned here to look for more opportunities. So I want to call out something that you're probably very, very familiar with. And also, if you haven't heard from my colleague, Rui Pereira de la Sala, I'm borrowing these slides from him, and I think that he and Chris Kondraki could certainly tell you a lot about the MIDRC Medical Imaging Data Resource Center and the work that they're doing. So I'll just highlight in case you're not completely aware of all of the work that they're doing to implement interoperability with the medical imaging data resource, as well as clinical pathology and omics data. And you can see their partners are N3C, Biodata Catalyst, and all of us, as well as potentially others. And so taking that concept that I talked about in terms of thinking about a safe environment, or sometimes you'll hear us talk about a free port, where we're thinking about ways in which we can instantiate a security and compliance boundary across different systems. Here, what MIDRC is thinking about is providing a way to authorize workspaces within that environment so that researchers can find and aggregate data. I believe that they're working very closely with you on PPRL, and they're certainly linking all that data through their honest brokers, you'll see in a minute, and then pulling that data most likely into a workspace. Rui told me about two general use cases that they're interested in. First of all, enhancing medical imaging by enriching it with clinical and outcome information. That outcome information could be past comorbidities, risk factors, to enhance greater cohort building, as well as data discovery by enriching the clinical information in N3C with medical derived parameters. So I think that these two use cases are highly important. And what Rui has told me is that you're right now in the process of actually utilizing the tokenization process and getting those tokens to the honest broker so that you can start to think about the ways in which you can bring those data sets together in a secure enclave. There's still a lot of work to do, but I think because the data that you're thinking about are not bounded by the genomics data sharing policy, you'll be able to fully enact your use case. There are other activities, for example, the activities in HEAL to build a community to generate helping end addiction long-term data, providing support for data management and broad researcher and user engagement. So right now they're looking at providing a sandbox for user-friendly search interface, providing compute on our cloud strides partners and analytics tools, as well as providing different representative data sets. HEAL also has some really nice activities that are happening in terms of helping researchers understand and implement FAIR data. So every week they do provide a sort of a training activity in FAIR data. There's also a sort of a data repository activity called the HEAL Data Fair activity. So there's quite a bit of work happening in HEAL to help researchers understand how to share data and how to make their data more fair and how to find a repository within the HEAL data ecosystem. So what does it look like to think about a data ecosystem supporting the FAIR principles, the CARE principles, and prospectively planning for how you'll handle data, instantiating our repositories to easily find, share data and metadata across multiple different repositories. We're starting with the Generalist repositories, enhancing researchers to bring in software engineers, enhancing best practices for software, and enhancing an open community to develop and share software engineering best practices. We're looking to enhance cloud-enabled data analytics and platforms to bridge silos across our different platforms, and to really think about sustainability and fair data sharing, making metadata more available and standards more computable, and then training colleagues across a vast array of biomedical data science, information, computer science domains, and finally partnerships in data science across national or international boundaries for sustainable infrastructure. Every month we do support an IC to talk about their data sharing and their data reuse within their IC. And so this month, or next month in April, we'll be hosting Dr. Adam Ferguson, who will present data sharing and machine learning for translational central nervous system injuries. He'll talk about the ways in which they're managing traumatic brain injury and spinal cord injury to develop a community data-driven sharing initiative. And he'll talk about how they're working to enhance machine learning on pooled data within their central nervous system brain injury data repository. All of this work doesn't happen alone. As I've said, there's well over 190 folks working with us. These are just some of our leads and some of our activities. And with that, I want to thank you for allowing me to come and tell you a little bit about some of the activities that we're supporting in the Office of Data Science Strategy and through our collaboration across NIH. And I think I have left time for questions if you have any, or just an open discussion if you would like.
Well, thank you, Susan. What a great talk. And I'm sure there are lots of questions. And I'll start out with a couple. One is, maybe you could talk a little bit about the role of proprietary data in this sort of ecosystem. So let me be a little more specific and say, okay, obviously if the data is extraordinarily proprietary, there's probably not much of a role. If the data is completely open, a la TCIA or whatever, then it's obvious what the role is. A lot of data is somewhere in between. And what is your thinking and your colleagues thinking about how this can be incorporated into sort of a ecosystem?
That is a really great question, because it's something that we've been talking about, not necessarily with respect to COVID, but certainly this has enhanced the discussions quite a bit. So I'm not sure if you're familiar with what's happening in the Innovative Medicines Initiative in the EU, but there's a project called Melody, and I'm sorry, I do not remember what Melody stands for, but the gist of it is bringing together 13 different pharma companies, which obviously have proprietary data, and they're not really that open to sharing this data. However, Melody is standing up a platform and a framework for a way in which to federate some really interesting machine learning algorithms across these different repositories that are held in the different pharma companies, mostly looking at ways to think about structure-based drug design, but potentially also bringing in other types of toxology data, or even potentially what would be really interesting is clinical trial data. or failed clinical trial data. So that's the most extreme component of proprietary data when we want to think about how we can build a platform that will leverage true proprietary data in a way. It is federated learning, so there's pluses and minuses to that. But it is something that I think that we're thinking of. I know that there's another pilot happening within DOE, and I believe cancer, that's sort of along the similar lines of bringing data into a secure enclave where nobody sees the data. You still do essentially federated learning on that. That is something that we are thinking about and applying in different ways. For example, the AIM-HEAD program is also constructing as one component of their aims a federated learning capability, not because the data is proprietary, but for other reasons. So I think that there's ways in which we can think about secure enclave computing and or federated learning to approach the true proprietary data that simply can't be shared in an easy way.
No, thank you. And obviously it goes without saying that N3C is an example of data that is certainly not open to the world without constraint. It's open to the world with a lot of careful governance and regulation. So let's see, I have another question, but I don't want to hog the floor. Does anybody else have anything to ask? Okay, so another question has to do with HPC and machine learning. So, and in our own consortium, we're working with Sam Michael and Ken on essentially HPC capabilities. But obviously, as you're talking about this broad pan NIH effort, application of AI methods generally requires this. So what are your thoughts or plans, or what are your office's thoughts and plans about making some of these data sets HPC accessible?
I think that's a great concept. I actually came from an HPC training and community, so I certainly have a certain affiliation. I do believe that, and you'll see this in documents coming out of OSTP and administration, that we have to think about a computing ecosystem. I hope that word isn't getting overplayed, but that there's different types of ways and we can think about computing. HPC, for example, is very, very strong in certain areas, including image processing, which struggles in the cloud for various reasons. And so bringing those data sets on an HPC environment and making them readily available for researchers is certainly a strength, and certainly a strength of N3C that I think we could learn from in ways that would benefit the greater NIH. So there are other capabilities that HPC brings in as well that are really strong for those activities. And also thinking now there's new talk about quantum and quantum computing. So there's certainly some capabilities there that could be explored. And so we do have to think about a computing ecosystem as we move forward. There certainly is no reason not to, but it does require a lot of additional research and activities.
Great. And Michael Kahn has a question. What are current thoughts about ensuring adequate and continued attribution as data sets are forked, modified, reforked, modified, reforked, modified, et cetera? What is the thinking about how lineage derivatives can be managed and acknowledged?
Yeah, that is a problem that we were dealing with even way back on the concept of how you mint a DOI for data set, and then you have all the forks and the children of those. And so I think this is something that actually needs a lot of further discussion, because there certainly is a lot of discussion about GUIDs in the way that you are persistent. I think they're now called persistent identifiers, and we've been thinking about how we can provide DOIs for data sets, but this is something that is of great interest, and I'm not entirely sure it's been completely solved, but has been at least thought about in the climate community, where you have data sets which are forked quite a bit.
Mm-hmm. Right. And Richard Moffat has a question following up on Joel's thread. How do we handle some data are available to use individually, but using them in concert requires further permission? For instance, N3C data and external death data requires site permission, to combine due to the increased risk of re-identifiability with each subsequent join?
Absolutely. This is another hard one. These are good questions, also very hard. And I think that this is something that we've also been thinking about in terms of how we can look at the data governance as we're thinking about an interoperable system where the data permissions have to follow the data across the system and also into the access passports of the individual. And so this is something that we are actively looking at as well. I can't say that I have a great answer. I think this also requires additional work, but it is something that we are thinking about in terms of how you can actually carry the lineage of the permissions and the governance of the data with you on your data passport as you traverse the data interoperable ecosystem.
So, and related to that, following up on Richard's follow-up on me, you also have the issue of models, in the sense that if you have a federated model or you even share models, then as everybody knows, depending on the details, there's a certain amount that can be reconstructed from these things. One would hate for the community to become paralyzed by conservatism about this. On the other hand, there are some cases that are, pretty obvious. What is your thinking and the people you're working with at NIH thinking about that issue?
Let me see if I have the question correct. In terms of attribution of software and models, or
no, in terms of if you train a model, then under some circumstances you can get identifiable information out of the model without actually knowing necessarily you've got a billion parameters and you poke it a certain way, out comes something that you weren't expecting to be revealed.
Yeah, this is at the heart of something that we've just started to look at. In fact, there is a NOSI, and I really wish I would put this slide in, for thinking about ethical frameworks for AI, of which this falls under, and asking people to help us think about those frameworks for how you can understand and know when what you've trained actually becomes an identifiable component. And then there's a really interesting paper that my colleague alerted me to that I can put in the chat, where recently folks who are looking at AI models for understanding brain images have been able to essentially through aggregating all those slices reconstruct the face. So
Right.
There's a perfect example of what you've just told me and what we need and what we're looking for in this NOSI solicitation is frameworks and ways in which we can help identify that sort of potential risk before and during while we're training the algorithms. So what I need to do is to put that notice in the link, and I'm going to do that now. I regret that I didn't put this in the slide, so I apologize.
Oh, and by the way, there is a question. I think there's pretty universal interest in getting copies of your slides, if you'd be amenable to that.
I would be most happy to do that. Yes.
I think Usman might have copies already, or if not, maybe he could distribute them. However you guys want to do it, but I'd be very interested. Question has been in chat for a while from David Sonner. He thanks you for a fantastic overview and says, given the compute demands of many machine learning methods, especially in the context of large data sets, any thoughts on leveraging tensor processing units to support analysis in a virtual workspace?
Oh, absolutely. Yes. Yes, that would fit quite well within our software NOSI for enhancing workflows and producing more scalable algorithms. So absolutely.
So another related question involving the HPC topic. So I've been on a couple of panels involving DOE, Department of Energy, and its interaction with the biomedical community. I mean, that's the part of it that I've dealt with or tried to help with. And so, as I'm sure you know, DOE is positioning itself as being the lead agency for AI, and certainly has been procuring exascale machines. And I know there's been active work. I mean, there's been active work with NCI that has gotten a lot of attention. Have there been discussions or plans in other parts of NIH involving teaming with DOE on exascale computing?
There have been some interest in partnering with DOE on exascale and sort of beyond computing in quantum information science and quantum computing in sort of instantiating PPRL in different ways or federated learning, as well as in a digital twinning. So we have had some discussions. Many of those would actually benefit from exascale computing. I think the work that's being done on cancer is certainly a good path forward for ways in which we can engage DOE and other computing capabilities as well.
Yeah,
Right.
Joel, this is, and Susan, thank you for the wonderful talk.
Okay.
Obviously, you know, very familiar with a lot of this at NIH, but I'm really glad that folks are seeing the capabilities of your shop and everything we're involved in. Joel, there's a pilot underway at NIH. I don't know how public it is, so I don't want to say just yet, but there's a pilot underway at NIH with them looking to expand the capabilities of BioWolf. That's the NIH HPC to greatly augment its capabilities with an existing platform. So I would say, your questions in this space are really pertinent. And obviously, we're trying to work with you guys on this.
Right.
I think NIH is actively pursuing ways to get access to additional HPC resources. I think that's the best way I'll say it. I think there should be hopefully news coming on that front soon, but there are some pilots going on, and we're and I can say that because we're engaged in one of them, which we're excited about, but we haven't gotten the results of any green lights yet.
No, great, Sam. No, and I know it's great working with you on this, and obviously as the infrastructure develops, then connecting this to exascale resources becomes more of a reasonable thing. Although there are interesting differences in programming models, as you know, in the sense that, or I suppose access models, compute access models, and that the DOE facilities are very wed to queuing systems, and
Yes.
on demand is something that they will support, but it hasn't been their primary thing. And this has been discussed, as you know, for like 30 years. I mean, this is not new.
Yes.
but to a certain degree, the medical use of high-end computing, used to be limited to things like computational chemistry and radiation treatment planning and things like that. I mean, there were uses for sure, but now with deep learning, it's become, almost universal. So I think we're out of time. So this was a really wonderful talk and a great discussion. And, I think that everybody in N3C is, really inspired by the potential use of or leveraging what, we've learned in our consortium in a broader sense, and as well as being able to leverage methods such as what Sam's talking about, you're talking about for our COVID research as well.
Absolutely. Thank you so much. This has been a lot of fun, and I hope that it will continue to talk, because a lot of the things that we're talking about, they're not solved problems. There's a lot of work that needs to be done. And so having your brain power and your thoughts, it just can help us so much.
Okay, well, thanks, and thanks everybody. Thanks, Susan, and have a great week.
Thank you. You too. Bye.
Bye.